I am Jane Wyngaard. I'm an electrical engineer at the University of Cape Town, and I am perhaps a strange addition to this workshop, but I want to bring to you a perspective, I guess, on a technologist's perspective on data sharing and the opportunities that are currently being presented to us as a continent, really, as the world changes how it handles academic data. And yeah, so in short, I'll talk a little bit about FAIR and what that is. So I'm sure a lot of this community is very familiar with it already. It's a buzzword that has popped up since around 2016 regarding how academia would like to handle and share its data. I'll talk about why I think FAIR is important for us. I'll talk about some very valid and appropriate reservations we, as an academic community globally, should have, but also particularly the African continent. And then also building on that, a bunch of opportunities that I see as the academic community is in this process of changing how it handles and manages data. I think there are a lot of opportunities for us to take advantage of. And so I'll talk through some of those and some of the open community doors. And so briefly, why I'm possibly even relevant here is a lot of the work I do at the moment is around data management for academic data coming off, or scientific data rather, coming off drones. And I think the complexity of the drone pipeline, the complexity of going from a sensor in the air on a drone through to published data set is similar, or at least analogous, to the complexity of the process that this community goes through, where from identifying larval breeding sites or capturing or doing mosquito trapping and processing those samples, validating them and moving them through multiple stages through to the point of actionable publication, whether that's publication for the sake of publication or publication for the ability of people, academics or municipal managers making actionable decisions. Yeah, I think the process is similarly complex, and so a lot of the work I'm doing at the moment is trying to build tools to facilitate fair drone data. In my case, it's often temperature or soil moisture, but I think the pipeline's analogous anyways, and so I think we share some common problems. Okay, so what is FAIR? Just as a recap, or for anyone who hasn't come across it yet, in short, it's an acronym for Findable, Accessible, Interoperable, and Reusable. So Findable being the idea that I would like to be able to go to Google data search, plug in, I want Cape Town air temperature between 2014 and 2018, and I would like to get a result. Accessible being, I would like that result to present me with an option to actually download the actual data set, not, I don't want a news article that talks about Cape Town temperature fluctuations. I want some sort of data set that I can actually download, maybe via a login. It doesn't necessarily need to be freely available, but I might just actually be able to get hold of the actual data. Interoperable, meaning that it needs to arrive in a format that I can interact with and that I can use. And it needs to be accessible, actually, equally in a manner that is practical for me, whether that is, if I'm trying to download data sets every single day, I probably need some sort of computer interface, not a website that I just click on. It's also part of accessible. But interoperable, so I don't want the Cape Southern Weather Service's internal data format. I want the data to arrive in a format that is commonly available. Also would prefer not to have the data set available in, say, the temperature sensor's proprietary format, whatever the manufacturer of that sensor used. It needs to be in something standard like CSV, or there are many valid standards at CDF, 100 different ones, but it needs to be something that I can access and something that I will readily have tools available to me for using. And then finally, this is really the crux of it. It needs to be reusable, and that means it needs to come with a lot of basic metadata regarding, in my example, the temperature values that would allow me to make actionable decisions on it. So
in my temperature example, it needs to come with information. Are these numbers in Celsius or Fahrenheit or Kelvin? What sensor was used and when was it calibrated? Where was this temperature sensor even mounted? Is this temperature data for every house in Cape Town, or is it just a single tower sitting on top of Table Mountain? All that information is essential, really, if I were to do anything useful with this data. So that's what FAIR is in very brief. If you're interested in more, obviously the paper is there, the original paper, or Go FAIR is a EU project, but they have some really good, just basic practical information about the FAIR principles, and highly recommend going and reading through what they have there. It's very accessible. So what is FAIR not? Often an immediate response to this is, but hang on, I have health data or conservation data. FAIR is not open. FAIR does not require that your data be open. Often it is, but that is not core to the FAIR principles. Similarly, it does not mean free. There is every reason, in many cases, to have findable, accessible, interoperable, reusable data behind a paywall. And then, in addition to that, FAIR is not a standard. We throw it around a lot it is being thrown around a lot, almost as if it is standard, but it's not the standard. What is, however, needed standards-wise is that all of our communities across, and each domain is having to do this to a large extent on their own, in order to implement the FAIR principles, in order for us all to make our data findable, accessible, interoperable, reusable, we are having to create standards. A lot of our communities have, for a long time, existed fine with passing PDFs or CSVs or whatever our format is around between internally within our communities. But if the data is to be fully fair, we need to all, as a global community, really agree on some standard ontologies or vocabularies, standard protocols, standard file formats, and standard machine, so computer APIs or frameworks, programming tools that allow the machines to do a lot of the work for us. And I'll get more into that. And then lastly, it's worth pointing out that FAIR does not in and of itself say anything about data quality or data ethics, although there is a lot of really good work going on in that space, but basic FAIR says nothing about that. So FAIR by example is actually quite hard to show because most communities are still wrestling with this, and this is why I actually think there's a lot of opportunity here for us in terms of, as the continent, the global community is wrestling with this, and there are opportunities for us to become leaders in this space. But best example I can find is actually Swiss government data. They have done quite a lot of work to make their governmental data both open and fair. So the example here is just two things, two human readable interfaces. Sorry. You can just see these two interfaces to some data sets, and the point being, pops up on a map and pops up with a bunch of metadata about whatever it is you're looking at, and it's obviously human readable, it's a web page. That does call out again, though, that the crux of this is often the metadata. It's the information about the data that is making fair, qualified data powerful. The other thing to point out here is, so in this example, we've pulled out some sort of region, apparently. I don't know if it's a suburb or a city. But in the Swiss terms, it's considered an administrative area. And what is an administrative area? And if I click on this administrative area link, it takes me to the schema.org, where administrative area is defined. Geographical region, typically under the jurisdiction of some particular government. This schema.org is a Google standard. And so what they've done is they're taking advantage of Google's standard terms, which means that anybody can arrive at the website, click on that, and get a definition. And additionally, because they're using Google standard, because all of us use Google, it means Google's bots will find this so that I can, in Google's data search, say, find me administrative areas in Switzerland, and it would take me straight to those. The other thing to pull out from this page is this same database is also accessible in machine readable interfaces. So
The first of those is Sparkle, which is a SQL query interface. And so here, this is the human interface to that SQL interface, but obviously a program, a script could be running their own queries. And what you get back, depending on what you're looking for and depending on what you ask for, is the raw data. And so the key component of FAIR is that the data is both human and machine actionable. And I'll get to why that machine access is so critical. But broadly, why should we care in general as academics? Start with that. About doing FAIR, pretty obvious reasons. For one, it increases accountability, integrity, reproducibility. By having all of us publish our data as FAIR, other researchers are then able to go and access the data and check that what we've said in our paper is true. It increases the reproducibility because now another grad student from the other side of the world can come and take your paper and first off reproduce what you've done and then build on that. And so obviously that is key in terms of advancing scientific progress. Rather than reinventing the wheel, if your work can accelerate mine, that's fantastic, and vice versa. And a very convenient byproduct for us is obviously that it increases collaboration, because if I'm doing key work that is building on yours, inevitably I'm going to make contact with you, or more likely probably want to extend the work and work with you in doing that. So that is a reason I see as a key motivator for us, at least on the continent, to start producing FAIR data, because it will bring new collaborators to us along with their money. It also removes gatekeepers, so both monetary and social. So by enabling me to publish my data as FAIR, I've removed the need for a journal to gatekeep that data, put their own paywall or otherwise on it. But it's also disrupting some of the academic, social, hierarchical gatekeepers on data. Because again, and this is particularly true in the drone sector where I'm working, many researchers at less well-funded institutions are doing critical and important work, and by publishing because they're at a low resource institution, they're not NASA, they don't have a whole department dedicated to helping them publish their data. But if the infrastructure exists for them to publish their data as FAIR, suddenly they are able to publish their work, at least the data, in a manner that the community is able to access it without some of the historical gatekeepers being there. And I see that as critical in terms of, as we think about the growth of citizen science. And so that's not just enabling citizens to contribute their data, although there are a lot of really interesting and important projects out there at the moment using citizens to collect scientific data, but also if we think about citizen action based on data, particularly I'm thinking around climate change, but I would imagine this is true around mosquito population information too. If citizens have access to that data, they are able to make responsible decisions / lobby their own governments more productively. Finally, just practically, many of our funders are now requiring that we publish our data as FAIR. And then arguably we potentially have a public responsibility to publish this data, because a lot of our research, but not all, is public money funded. Finally, and I started alluding to this, we as the academic scientific community, frankly, we need FAIR. We need our data to be FAIR, because I'm sure you are seeing as well that increasingly the scientific questions we're all attempting to answer require such a breadth of integration of both disciplines and data sets, that we need machines to be doing a lot of the integrating work for us. And on top of that, depending on what we're doing, a lot of our data is starting to come in at a rate that a human simply cannot handle it. So going back to my temperature weather service example, if the application that I'm interested in requires daily temperature data integration updates, it's just inefficient for me or even a grad student to be going to the Weather Service's website daily and downloading that new data set. We need the machines to be doing this. Never mind the fact that that's completely implausible. More likely, I'm downloading the data set from both NASA and ESA and potentially Chinese satellites all at once and integrating that with local temperature data set. So we need the computers to be doing a lot of this work, and publishing our data as truly fair, will facilitate a lot of that computer level automation. So I did say I talk a little bit about justified reservations, and these are justified. So particularly in this, I think health data, human health data is the first thing that springs to people's mind, genomic data, when we think about privacy. In the drone sector, I've done some work around conservation of rhinos or critically endangered vegetation species. And so obviously in those cases, access to that data needs to be controlled. Or if we think about data that might indicate the presence of minerals or other natural resources, again, there absolutely needs to be valid control and access limitations to that. We can also talk about valid reasons to give yourself time to publish before others are given access to your data. And those are all absolutely valid concerns. Within Africa, obviously, we have a long history, frankly, of data exploitation, whether that's theft of our data, misreuse of that data. Again, reasons to be justifiably cautious. But again, two things. Fair doesn't mean open. And there's some really good work happening, and I call out the SAN Code of Research Ethics as one of the best examples, happening on the continent and elsewhere in the developing world, where we are putting together best practices and standards of requirement that external researchers need to adhere to. And so this actually, the SAN Code of Research Ethics predates FAIR, and they put this together because they were being subjected to a range of abuses. And so now anybody who does any research, any data capture on the SAN community is required to abide by this code of ethics, which is great. So my point is, A, we can still control access to our data and be fair. And so we can gain all the advantages of FAIR while also avoiding exploitation, frankly. And there are good examples out there that we could look to in terms of starting to define some of these practices and how we want to control that process. Then lastly, obviously, we have the practical question of sustainability. Implementing FAIR requires, well, apart from anything else, work on both the part of the researchers and infrastructure development, and work requires money. And so there is a question of both immediate resource gathering and long-term sustainability. My colleagues in the University of Cape Town's e-research center battle with this a lot. So they run services that allow UCT researchers to publish their data locally, hard drives and compute access. And it's a constant battle to find the money to fund their services. However, I think there are opportunities for us to leverage on that. So this is quite a cool image. It's all the way back from 2011, but this is road, rail, undersea cable, and data lines. So the undersea data lines across the African continent, highlighted in this nice image. So we have a lot of infrastructure, is my point. And I'm aware, coming from South Africa, that looks slightly different to other areas on the continent, but I do quite a lot of work with the high-performance computing community here, and I know there are some really good projects that span Africa, deploying compute resources, data storage resources, and I think a lot of that could be built on. So really, that's one of the opportunities I see. As connectivity is rapidly growing across the continent, we can take advantage of that. And one of the key things there is we could take advantage of this to publish and locally host and publish our own data. There's no reason for our data to end up sitting on data services elsewhere. There's every reason for us to build infrastructure, and that's both infrastructure and people, skill, capacity, locally to enable fair hosting of our own data. And one of the components of that opportunity is that, as I've said, the world is still working to work out how to practically do fair. And so there are gaps in that both infrastructure and technological and skill set stack that there's no reason African researchers and computer experts couldn't step into. Finally, this is a great opportunity for us to claim credit for our data, both researchers and data capturers. FAIR enables that, but so by adopting the FAIR principles, we automatically gain credit for that data capture work. And then, as I mentioned, by implementing FAIR principles, academic community as a whole benefits. We accelerate our scientific advancements because I get to more easily build off your work. We accelerate and improve collaboration because it's much easier for me to work with you, and I'm more likely to even discover you exist. And so that is true on a global scale, so no less true on a local scale. And so by implementing FAIR across the board, we will advance African research. So FAIR practically, and so I'm afraid I can only speak from my experience in the drone domain, but just to call out how it requires a very wide community-based effort, all that work to develop even just a standard ontology, so a standard set of terms that we want to use to refer to sensors through to, I know this community has controlled vocabularies regarding mosquito species, for instance, but coming to global consensus of that requires discussing in the global community. But alongside that, there are a lot of existing standards. So in the drone community, remote sensing obviously is a long-standing mature field from satellite and manned aircraft. And so we are building on a lot of those standards. Similarly, when you talk about machine actionable data, there are a lot of, and growing and developing actively, standards that exist for that. So for instance, the Google schema.org set of terms is already an established term, and I mentioned that there is work underway to develop scientific, it's literally called science on schema. So scientific terms for defining a data set, or a researcher, a principal investigator, a funder, a publication, all of that, that terminology is being built out by, well, actually ESIP. And then in the drone context, I highlight ENVO and TURN. ENVO is a Europe-based organization, and TURN is an Australian-based organization. And then myself, in collaboration with a bunch of Americans, are all working together to define what a drone is and how you mount a sensor on the drone, all that kind of new terminology that has never been defined before. Some more practical resources. So if perhaps you are a computer scientist wanting to take actionable steps towards facilitating your local researchers publishing their data fair, how to make your data fair is another EU project that has some really good resources on it. Best practices for implementing fair vocabularies and ontologies. So that is a fantastic paper that I think is actually 2020. It's pretty recent, but it walks you through the state-of-the-art tools and practices available for publishing your, often what is just a community vocabulary, so your standard set of terms for talking about the parameters in your community as a fair ontology in a both human and machine accessible format. So really good paper. And then I put a link to one of the drone projects that I'm working on, which just has a bunch of simple resources. Go have a browse. This picture is quite cool. So this is probably not a complete list, but a picture of the biggest and most widely used linked data vocabularies. So fair, actionable vocabularies already out there. If schema is that Google one that I mentioned, I use prov, which is about capturing the provenance of your data. So terms for talking about the different stages that your data processing goes through. I use SSN, which is about sensors. What's missing here is anything about drones, and so that's one of the things I'm building. I'm sure there's a lot here that is of relevance to this community. Time, where all of us are time stamping our data capture. We're all using that. Okay, so some other communities. African Open Data Network is a really great project. I think they have some really great and ambitious goals. Personally, I haven't had any really practical, technical community work driven out of it. However, I do find their newsletter really useful, just to tell me what's happening in the data space all across the continent. So if nothing else, worth signing up for their newsletter. And then the logo for RDA, Research Data Alliance, has come up a couple times, and I want to call them out. So they are a global organization, primarily sponsored by Australia, the US, and Europe. However, Botswana is a top-tier level member, and as a consequence, in 2018, Botswana hosted the International Data Week, which is primarily RDA with a couple other data organizations attached to it. Their tagline is building the social and technical bridges to enable open sharing and reuse of data. And that really is what they're doing. They're an intersection between data experts, so often librarians, information managers, technologists like myself, and then domain scientists. And they're within the organization are, I don't know, probably at least 100 different groups that are all focused on different aspects, often specific domain aspects. It's free to join, free to take advantage of their communities, and primarily, I would say, take advantage of accessing the data experts in that community. Two things to call out. One, there isn't a vector community in there at the moment, so it would be great for somebody to potentially start one if that would be of value to this community. And then the other thing is, one of the working groups in the RDA is a data science training school, and their materials are freely available online if you just want to go through them, but they also are worth joining their mailing list because they advertise regular training updates. Don't know how they're handling COVID. I assume they're doing things remotely. Funding. So Wellcome, Belmont Formats, and Horizon 2020 are just publicly available funds that I know of that regularly fund data infrastructure and data tooling work. NIH DSI Africa is a recent call from the NIH, which I know some people in this community are actually looking at, but it's tailor-made for African researchers thinking about data that has anything to do with health science. So yeah, it would be really exciting if people in this community are able to win the money from that call. And lastly, I'll say I'm happy to keep talking more about if this is of interest to anybody. Again, as a recap, FAIR benefits us, and it's worth pursuing both as academics in the global context and as academics in the African context. It lets us control the narrative and access to our data. It will accelerate our own scientific work. It will accelerate our community work amongst ourselves and internationally. And there are opportunities because the way academia is handling data is changing. There are opportunities for us to grow our local infrastructure, grow our local skills, and change how things are done in academia as a whole. And finally, it's good for our societies that a lot of our publicly funded data capture work is that data is made accessible to citizens in general. So yeah, would love to talk more, and I will be in some of the live sections next week, however that's going to work. Thanks.